Good morning, guys. This is one of my first, actually this is my first instructional video. I'm trying. I know there's going to be a lot of glitches and tough moments, but I appreciate you guys hanging in there with me and all the support. Yeah, let's get into it. What's up, everybody? Good morning. Let's try to do an instructional video. Let's get right into this. I'm using this stylus type thing, a graphics tablet, to try to draw these lessons out. Let's do this. Okay, in the past, we know we have studied something, of course. Linear equations, which we said generally take the form y equals mx plus b. There's also, of course, the standard form, ax plus by equals c, amongst other forms. And we said if you graph a linear equation, visualize your coordinate plane. We said these, as the title indicates, are straight lines, right? And these lines have features. They have a slope. They have an intercept. Where does it cross the y-axis? Where does it cross the x-axis, right? But then we moved on. We started to learn lessons on polynomials, specifically trinomials. We did factoring, quadratic formula, some other things, and we started to look at numbers in this form. The following: ax squared plus bx plus c equals 0. Okay, as you hopefully recall. Okay, when we worked with this a lot. And this is what this is, a quadratic. And we once said the quadratic, especially indicated by this exponent. That's how we know, right? The linear equation did not have an exponent. Okay, so we want to start graphing these. The graphs of quadratics are not straight lines, right? Here's some coordinate plane. A typical quadratic will have sort of a letter U type shape. I'll try to draw one like this. This drawing is kind of bad. And this shape is called a parabola. These shapes, these parabolas, can also open upside down. And even sometimes you will see them eventually open sideways. Sorry about those arrow tips. Okay, so that's sort of our background. Now let's take the next step and learn some of the details about these parabolas. The most basic parabola takes this form. That's the most basic parabola. You might be wondering, what is this? This is the exact same thing as this. Except in this problem, A is effectively 1, so we don't write it in. B is effectively 0, so it sort of just dissolves out. And C is effectively 0 as well. So we have this sort of simplified equation, y equals x squared, one of those simplified trinomials, right? But excuse my drawing skills. Let's try some other tools. You can use this website Desmos. Many of you have heard of this, okay? So as you can see, I've inputted a very basic function, y equals x squared, right? A quadratic basic example. And notice how it's graphed. I'll do it live for you. Y equals x squared. We put that square on it, boom. We get this shape, as you can see, right? This is the parabola. Now, this parabola and all parabolas have some special properties or characteristics, right? Just like linear equations had some certain characteristics, like a slope and a y-intercept, these will have some special characteristics as well. One of them is the vertex. The vertex is sort of the center, you might say. It's kind of where these two left and right sides emanate from or originate from, right? So this vertex in this problem is 0, 0. Notice that the vertex is an ordered pair, x, y. So it's 0, 0. Now that can change. A second special property of quadratics is this center line, right? This is known as the axis of symmetry, okay? So the axis of symmetry. We also have the vertex. You said the vertex is an ordered pair, so it should be in the form of x, y, right? Two numbers. Now, the axis of symmetry, let's think about this. An axis is basically what? A line, right? So it's a line of symmetry. Should be basic for most algebra students, okay? We kind of inherently should know what symmetry is at this point. I don't think I need to re-explain that, okay? So this is that line. In this case, it actually is the black line in this example, right? Now, because it's a line, think about that. A line is a linear equation. So every line has its own equation. So the axis of symmetry actually is its own equation. But it will be a linear equation. It will not have an exponent, right? So linear equation of the axis. And it's going to be a straight line. Think about this. This is the line, right, where x equals 0. All right, guys, so we're looking at the axis of symmetry and the vertex. They're very much highly connected and interrelated, okay? The axis goes through the vertex. Where's our Desmos, right? So we have the vertex, which is a point. The axis is a line, right? And that line passes through the point. So we have to see this connection. The vertex and the axis of symmetry are highly connected. The axis of symmetry passes through the vertex. That's going to be important. So to find the axis of symmetry, we were saying it's a linear equation. It will be in the form that they call negative b divided by or over 2a. Negative b over 2a. Well, let's apply that to this math problem, this very basic example, y equals x squared, right? We said in this problem, a is 1, invisible 1, and b is 0. So if we're showing our work, this is saying negative 0 divided by 2 times 1. This is the same thing as, of course, 0 divided by 2. And 0 divided by anything is 0. So we got that equation that I told you, x equals 0. Okay, so that is our axis of symmetry. This is the formula for it, negative b over 2a. Now, to find the vertex, that actually is the x-coordinates. You just found half of your vertex already. When you find the axis of symmetry, you find half of the vertex by default because it's an x value. However, you still need the y value, right, to complete the vertex. So you very simply take your answer for the axis of symmetry, your x value, and you're going to plug it into this equation, into this function, into the quadratic itself. So if we plug in 0 into y equals x squared, right? Y equals 0 squared. Sorry, I can't type an exponent on this. 0 squared means 0 times 0, which is 0. So in this problem, we get the ordered pair, 0, comma, 0. This is the basic example, right? The vertex, and we can prove it, right? There's the point, 0, 0. You can see it in the graph. That's the vertex. It's at point, x, comma, y. And we have the axis of symmetry, which is a line passing through the vertex, okay? Now, let's think for a second. There's a lot of other variables here, a, b, and c. This coefficient a, that has some special properties in itself. So if a is a positive number, like it is in our example here, right? We said it's positive 1, invisible 1. In that model, the graph of the parabola will open upward like this. But when it's negative, when a is a negative number, if I make it negative 1, you can see what's happening. It opens downward. Okay, so what does that teach us? If a is positive, it's going to open upward. If a is a negative value, the parabola is going to open down. Okay, which then brings us back to the idea of the vertex. The vertex will either be known as a minimum if a is positive, right? You can see in our prior example, when a was positive, this is the minimum value, it's the smallest value. However, when a is negative, it's now a maximum. The vertex is the maximum value. So we have the idea. All right, guys, we're going to try a real problem, a normal example, okay? And you can see we have y equals negative 3x squared minus 6x plus 4. And you can see next to that I have the process that we're going to try to follow, right? First, we're going to find the axis of symmetry. The answer will look like x equals blah. Then we'll find the vertex, which will be a point x comma y. We'll determine if that vertex is a maximum or a minimum. We'll also find something called the y-intercept. Where does this parabola actually cross the y-axis, right? So let's get into this. Find the axis. Okay, so here's our equation. What do we need to do to find the axis? All right, so here we go. We're going to use our formula. What did we learn earlier? We said x equals negative b over 2a. So in this problem, negative b. So we see b is negative 6. So negative of that is positive 6. 2 times a is negative 3. So what are we getting? 6 over negative 6. which is, of course, -1. There it is. We just found it. Boom. X equals -1. Okay, that's a line. That's the axis of symmetry. Now we need to find the vertex. We have the x value. We need the y value. How do we get it? Very simple. I'm going to take this, like literally plug it in. Wherever you see x, you're going to replace or substitute to create the following. -3. Instead of x, we're replacing. Okay, so you can see how I replaced x with -1. We can process this out, and what happens? Let's do this. Remember, PEMDAS, right? So we're going to do our exponents first. -1 squared is +1. -3 times +1 is -3. Negative times a negative is positive. Bring down the +4. No, this pen is really tricky to write with. So I'm still learning, guys. Thank you for your patience. And of course, what will this simplify into? +7. So now we have this answer, -1, 7. That's the vertex. We could actually now start graphing this, but that's not even the point of today's lesson. Question 3, is this a max or a min? Well, look at the value of a, right? The coefficient of x squared is a. A is negative. So this is going to open kind of upside down or downward, which means the vertex is actually a max value. Correct? And now for the y-intercept. Well, that's when, we said x equals 0. So if we go back to this original equation, instead of replacing -1 for x, replace 0 for x, right? 0 squared is 0. -3 times 0 is 0. -6 is 0. Right? 0, 0, 0. We get 4. 4.